So today we're going to start on preliminary 3, which is informal geometry and measurements. And I've been using a little bit of this notation already in the lectures, but this is where the actual material will be presented formally to you for the first time. And a lot of this lecture is notation. Notation is very important in math, and especially in geometry. The slightest little bar or arrow can make all the difference in what you're trying to say. So here we have the position of a point X on a line AB. Lines are denoted with arrows going in either direction. And so this would be line KF. And if I want to show that there is a point in between KF on that line, we would say that point K, point T, and point F are co-linear. They're on the same line. And we would write that KTF. That means that point T is between K and F. I could write it FTK as well, just pointing out that the point T is between the points K and F. So there is a concept of betweenness when points are on a line. So if a drawing is not provided, the notation A-B-C implies that they're all on the same line. So if I saw A, B, C written like that, I would assume that there was a line with a point A. I don't exactly know where point B is, but I know it's in between A and C. They are collinear. Here's an example of if this is A and this is B and this was point C. That's an example of those would not be collinear. They are not on the same line. So this notation means collinear. And then you've also probably used the terms angle, triangle, and rectangle, but let's make sure we know the geometry notation for these. Angle, an angle has a vertex. This point right here is called the vertex. And if I have point D, point R, point L, I would call this angle right here, we're going to have the little angle measure, that's the angle DRL. You know what? It could also be called the angle LRD. The important thing is that the vertex is the middle point of the name of the angle. Now, if there's no ambiguity in the diagram and you couldn't get confused, you could also just say angle R. Since there's only one angle R on the page here, I could still just say angle R. But so that would just be the name of the vertex. The vertex is a very important point in an angle. How about triangle? Here's my triangle. A triangle is a three-sided object. If I have, let's say, B, R, T, we would call this triangle B, R, T. Or we could start over here. We could call this triangle R, T, B. Or you could start at T and go this way around the triangle for the name, or start at T and go this way around the triangle. And then rectangle. A rectangle has opposite sides of equal length. So if I want to call this triangle CALP, that would be triangle CALP. You have to go in order. CALP. I could also have named it LAP. A, C, P. I could start at this corner, L to A to C to P. I could not call this L, A, P, C. L to A down to P. No. The vertices have to be named in order. And that's true for any type of geometric shape. So here, can this rectangle be named XYZW? Oh, sorry. Sorry, let's do this page. So a line segment has two endpoints, two distinct points, two endpoints. So here I have a line segment B and C. We would note that as the line segment. Notice there are no arrows. That is a segment. It has an endpoint at B and an endpoint at C. Now, when we come to measure, when we start measuring lengths, the length of a segment will just be the names of the endpoints. So this is a line segment. This is a length, which means it's a number, which means we can multiply by 2, we can divide by 2. So there is, when you omit the segment symbol above, that means it's the length of a segment. So now let's look at this example. So here we have this rectangle. Can this be called rectangle XYZW? So if we start here at X, XYZW. Yep, they go in order. That would be a valid name for that rectangle. How about WYXZ? Well, let's start at W. WY. Nope, you can't name, in this name you cannot go from W to Y, so we would say no, that is not a valid name. We're just getting used to the naming conventions. So now measuring segments. All line segments have length, and length is always positive. You wouldn't have a negative length for like the side of a triangle. And what are we going to use to measure length? Well, we're going to use our ruler. And so for this ruler, it's good to, boy, this ruler's pretty old. Look at this ruler has been through the war, huh? We have centimeters on this side of the ruler, and then this one is also inches on the other side of the ruler. Now, for those of you that really want to get serious about geometry, there is this template so that you can draw your triangles and draw your rectangles, and it is actually very good for drawing very neat notes and such. So you can get that at most school supply stores, or you can certainly get it online. I know the ECC bookstore sold it, but there are different rulers along the edges of this template as well. But you're going to need some sort of measuring device. And when it comes to measuring angles, we're going to use a protractor. My protractor doesn't have it, but many protractors will have a ruler down along the bottom part of your protractor. So it's up to you to find out what you've got here. Now, so if we're going to use just a regular ruler to measure a line segment, the important thing to remember, okay, for instance, in this case, let's say that we're going to do inches. We're going to put the endpoint at the 0. We're going to put the endpoint at the 0 marking on the ruler. Some people make a mistake and go to the end of the ruler. That is a mistake. This is extra space here. My 0 actually starts here. So that's what I want to put at my endpoint. And then, so here, if we're looking at inches, here's 1 inch, here would be 2 inches, here would be